Quantum fire reality. Forget everything you thought you knew about empty space. Seriously, erase the image of a cold, black, desolate void. The idea of a perfect nothingness, a silent, static emptiness between the stars, is one of the most profound illusions we've ever held. The truth is infinitely more chaotic, more energetic, and frankly, more terrifyingly alive. The universe's greatest secret isn't hidden in a distant galaxy or a black hole. It's right here, in the space between your fingers, in the gap between atoms, in the supposed nothing that fills this room. That nothingness is a lie. What we call the vacuum is, in reality, a seething, violent, incandescent ocean of pure potential. It is a hidden, universe-spanning fire, and its embers are the very building blocks of existence. To understand this, we have to journey to the absolute bedrock of reality, to a place where our common sense breaks down completely, the quantum realm. At this fundamental level, the universe operates by a different set of rules, the most famous of which is Heisenberg's uncertainty principle. We usually hear about it in terms of position and momentum, that you can't know both perfectly at the same time. But there's another, even more crucial version of this principle. It states that you cannot perfectly know a particle's energy and the duration of time over which you measure it. This energy-time uncertainty isn't just a limit on our knowledge, it's a fundamental law of nature. And it has a staggering consequence. For very, very short moments, energy can be borrowed from the vacuum itself. The universe allows for a temporary violation of energy conservation as long as the debt is paid back almost instantly. And what does this borrowed energy do? It creates matter. Out of absolutely nowhere, a particle and its antimatter twin burst into existence. They live for an impossibly brief time, a fraction of a nanosecond, before they find each other, collide, and annihilate, paying back the energy they borrowed and disappearing back into the nothingness from which they came. These are called virtual particles. They are not a theoretical fantasy. They are a constant, roiling feature of the cosmos. Every cubic centimeter of space, including the space inside your own body, is a non-stop fireworks display of these phantom particles. Imagine an ocean that looks perfectly calm from the surface. But if you could look beneath, you'd see a maelstrom of currents, eddies, and pressure waves. The vacuum of space is exactly like that. It's a turbulent quantum foam where reality itself is constantly bubbling and fizzing. This constant activity means that empty space has an inherent, irreducible minimum amount of energy. Even if you could cool a box down to absolute zero, the coldest temperature theoretically possible, where all classical motion ceases, this quantum activity would remain. This rock-bottom baseline energy of the universe is called zero-point energy. It is the heat of our secret fire. It's not heat in the traditional sense, but it is an immense reservoir of power, latent and humming beneath the surface of everything. How much energy are we talking about? Well, the theoretical calculations are so mind-bogglingly huge that they've caused a crisis in physics. Some estimates suggest that the energy density in a single cubic meter of empty space is greater than all the energy contained in all the matter in the entire known universe. It's an almost infinite furnace. Now, this sounds like science fiction. If there's a universe-powering furnace in every coffee cup, why can't we see it or feel it? For a long time, this was just a bizarre prediction of quantum theory. But then we found proof, hard, experimental proof. It's called the Casimir effect. In 1948, Dutch physicist Hendrik Casimir proposed a brilliant experiment. Imagine taking two perfectly smooth, uncharged metal plates and placing them incredibly close together in a perfect vacuum. Outside the plates, virtual particles of all possible wavelengths can pop in and out of existence. But the plates, only virtual particles with wavelengths that fit perfectly into that tiny gap are allowed to exist. This means there are more virtual particles pushing on the plates from the outside than there are from the inside. The result? The plates are forced together by the pressure of pure nothingness. This isn't a theory. It has been measured in laboratories with incredible precision. The quantum foam is real. The fire is real. It exerts a real physical force. This changes everything. Space is not a passive stage on which the drama of the universe unfolds. Space an actor. It is a dynamic, energetic medium that influences everything within it. This zero-point energy is thought to be the driving force behind the accelerating expansion of the universe, what we call dark energy. The very fabric of reality is being stretched apart by the latent fire of the void. So, the next time you look up at the night sky, don't see emptiness. See an ocean, see a furnace, see a hidden reality of unimaginable power, a quantum fire that has been burning since the beginning of time and will burn until the very end. The fundamental question then isn't whether this fire exists. The question is, if we are swimming in this invisible ocean of energy every second of our lives, is there any way for us to feel the heat? Is there a way to prove with our own bodies that this cosmic fire is real? The answer is yes, and it's a law you've probably never heard of. Unruh effect explained. So, the universe is secretly blazing with a hidden quantum fire. A constant, roiling sea of zero-point energy fills every inch of existence. But if it's everywhere, why is space so famously deadly cold? Why don't we feel this incredible energy? The answer is as profound as it is simple. We don't feel it because we are not moving correctly. To perceive this fire, to feel the heat of the void, you don't need a special spaceship or a powerful telescope. You just need one thing: acceleration. This is the key that unlocks one of the most bizarre and forgotten laws of physics, the Unruh effect. First predicted in 1976 by physicist William Unruh, this principle forges a shocking link between motion and reality itself. It states that an accelerating observer will perceive the vacuum as a warm bath of thermal radiation, while an observer in constant steady motion, what physicists call an inertial frame, will perceive nothing at all. Let that sink in. The same patch of empty space can be perceived as either absolute zero or a warm glow, and the only difference is you. Your state of motion determines the temperature of reality itself. How is this even possible? To grasp it, let's revisit our quantum foam, that sea of virtual particle pairs popping in and out of existence. For an inertial observer, someone floating gently through space, these pairs are perfectly symmetrical. A particle and its antiparticle are born together and die together in an instant. The net result is zero. Nothing is created. The vacuum remains a vacuum. But for an accelerating observer, the picture changes dramatically. Imagine you're in a rocket ship that is firing its engines, pushing you faster and faster. Your view of space-time itself becomes warped. Because you're constantly changing speed, you create something called an event horizon behind you. Just like the event horizon of a black hole, it's a point of no return for light and information. Now, picture one of those virtual particle pairs popping into existence right near your horizon. It's possible that one particle, say the electron, appears on your side of the horizon, while its partner, the positron, appears on the other side. Before they can annihilate each other, the positron is swallowed by your horizon, lost to you forever. From your perspective in the accelerating rocket, you just saw a lone electron appear out of thin air. It's no longer virtual. It's a real particle with real energy. And because this is happening constantly all around you, you find yourself surrounded by a steady fizz of these newly real particles. This fizz, this constant bombardment of particles forged from the vacuum by your own acceleration, is what you perceive as heat. The vacuum literally begins to glow with a specific, measurable temperature, known as the Unruh temperature. This isn't just a clever analogy. The Unruh effect is a direct mathematical consequence of combining quantum field theory with the principles of relativity. And it has a very famous, very powerful cousin, Hawking radiation. The Unruh effect is essentially Hawking radiation for an accelerating observer in flat space. Near the event horizon of a black hole, the immense gravitational pull is equivalent to an extreme acceleration. An observer hovering just outside the black hole would be accelerating ferociously just to avoid falling in. According to the Unruh effect, they would perceive the surrounding vacuum as being incredibly hot. Some of the particles from this thermal bath would escape, and that escaping radiation is what we call Hawking radiation, the glow of a black hole. The two phenomena are two sides of the same, deeply strange coin. Now, let's bring this back to the title of this video. Your motion proves this. When you get in your car and hit the gas, you are accelerating. When you jump in the air, you are accelerating. According to the Unruh effect, in those moments, the vacuum of space becomes, for you, infinitesimally warmer than absolute zero. The temperature is, of course, ridiculously small. For an acceleration of 1g, the same as Earth's gravity, the Unruh temperature is about 40 quintillionths of a Kelvin. It is so mind-numbingly cold that we have no hope of ever measuring it directly for everyday objects. But that doesn't matter. The physical law is absolute. The effect is there. The very act of you moving, of changing your velocity, is tangible proof that you are interacting with the quantum foam and changing your perception of its fundamental energy. You are, in a very real sense, fanning the embers of the universe's secret fire. This is the ultimate takeaway. Reality is not a fixed, objective stage that we simply move across. The observer is not separate from the observed. Your state of motion fundamentally alters the very fabric of the reality you perceive. The question of what is real becomes real for whom? The cold, empty vacuum and the warm thermal bath are both equally valid descriptions of the same patch of space, dependent entirely on the observer's acceleration. We are not just passive witnesses to the cosmos, we are active participants, co-creating our physical reality with every step we take. The universe isn't just out there, it responds to us, revealing its hidden depths, its secret fire, to those in motion.